Greetings to everyone, be it sir, ma'am, or my fellow friends. Before I start, allow me to briefly introduce myself and this video. I'm Roseanne from KT2 of KTA. This video is about my chemistry assignment for Chapter 4 Periodic Table, and I'm going to talk about an element I chose from the periodic table. Now let's get started. The element I chose is bismuth. Bismuth is a post-transition metal in group 15, period 6, and the P block of the periodic table. Now let's go to the history of bismuth. Bismuth has been known since ancient times, but was often confused with lead and tin because of its resemblance to those elements. Bismuth was first shown to be a distinct element in 1753 by Claude Geoffroy the Younger. It was one of the first 10 metals to have been discovered. Bismuth does occur free in nature and in such minerals as bismuthinite and bismite. The largest deposits of bismuth are found in Bolivia, although bismuth is usually obtained as a byproduct of mining and refining lead, copper, tin, silver, and gold. Bismuth is a chemical element with the symbol Bi and atomic number 83. Pure bismuth is a white brittle metal with a slight pink color. Often with an iridescent oxide tarnish showing many colors from yellow to blue, the variations in the thickness of the oxide layer that forms on the surface of the crystal cause different wavelengths of light to interfere upon reflection, thus displaying a rainbow of colors. When burned in oxygen, bismuth burns with a blue flame and its oxide forms yellow fumes. Bismuth has a melting point of 271 degrees Celsius and boiling point of 1564 degrees Celsius. It is at solid state in room temperature. Bismuth has density of 9.79 grams per centimeters cubed and relative atomic mass 208.980 grams per mole. The most striking thing about this element is that it is diamagnetic, and no other metal is verified to be more naturally diamagnetic than bismuth. Basically, this means that bismuth is repelled by magnetic fields, and in turn creates a repulsive force, pushing magnetic objects away from it. In practice, this means that if you place a magnetic metal between two pieces of bismuth, it will levitate. Bismuth is stable to both dry and moist air at ordinary temperatures. When red hot, it reacts with water to make bismuth 3 oxide. Also, it reacts with fluorine to make bismuth 5 fluoride at 500 degrees Celsius or bismuth 3 fluoride at lower temperatures. With other halogens, it yields only bismuth 3 halides. The trihalides are corrosive and easily react with moisture, forming oxyhalides with the formula BiOX. Bismuth dissolves in concentrated sulfuric acid to make bismuth 3 sulfate and sulfur dioxide. Besides, it reacts with nitric acid to make bismuth 3 nitrate. Bismuth also dissolves in hydrochloric acid, but only with oxygen present. Bismuth forms trivalent and pentavalent compounds, the trivalent ones being more common. Many of its chemical properties are similar to those of arsenic and antimony, although they are less toxic than derivatives of those lighter elements. Bismuth atoms have the same electronic structure in their outermost shell as do the other elements of the nitrogen group. They can therefore form 3 single covalent bonds, exhibiting either a positive 3 or negative 3 oxidation state. The bismuth atom consists of 83 protons, 126 neutrons, and 83 electrons. Bismuth is usually mixed with other metals, such as lead, tin, iron, or cadmium, to form low-melting alloys. These alloys are used in such things as automatic fire sprinkler systems, fire detection systems, and electrical fuses. Bismuth is also widely used as a colorant in cosmetics. For instance, bismuth oxide is used as a yellow pigment in paints and cosmetics. Bismuth oxychloride is used to make a pigment known as bismuth white, and bismuth carbonate is used to treat diarrhea and gastric ulcers. Bismuth also makes extremely beautiful geometric crystals if you melt it down, then cool it really slowly. This is how it looks like. Bismuth has unusually low toxicity for a heavy metal. As the toxicity of lead has become more apparent in recent years, there is an increasing use of bismuth alloys, presently about a third of bismuth production as a replacement for lead. Bismuth was long considered the element with the highest atomic mass that is stable, but in 2003, it was discovered to be extremely weakly radioactive. Its only primordial isotope, bismuth-209, decays via alpha decay with a half-life more than a billion times the estimated age of the universe. Because of its tremendously long half-life, bismuth may still be considered stable for almost all purposes. That's all from me. Thank you for watching till the end. I hope you enjoyed the video.